welcome back. Let's continue with the second learning objective, which is to use the method of completing the square to integrate a function. Well, to start off, this is a very strong method to integrate especially rational functions whose bottom is a quadratic. And let me just explain quickly how this technique works. Essentially, you start with a quadratic of the form x squared plus bx plus c. All you're going to do is to add and subtract b over 2 squared. Okay, so you add and subtract, so you still have the actual x squared plus bx plus c. But by doing that, the first three terms add up to a perfect square of x plus b over 2. So as you see that this turns out to be this perfect square. And you also have the leftover terms here, minus b squared plus c, that's carried forward. So this way, you have a perfect square x plus b over 2 squared, and you have a constant term minus b over 2 squared plus c. So this is how you complete this quadratic to square. Again, all we're doing is adding and subtracting b over 2 squared and writing the first three terms as a perfect square. So let's try this on an example here. And since we have a quadratic in the bottom, I'm going to try to complete it to a square, but let's first figure out what b is. Well, you have a b, this coefficient, -4, so that b over 2 equals -2. So all I'm going to do is to add and subtract b over 2 quantity squared, which is 4. So I'm going to add and subtract 4. I'm going to use a different color here. Plus 4, minus 4, and plus 7. So I can perfectly see that the first three terms add up to x minus 2 quantity squared. And then you have these two constants adding up to 3. So this is x minus 2 squared plus 3. So we are done with completing the quadratic to square. So I can also write this as the sum of the squares. Okay, so now the bottom here is written as sum of the squares. So this resembles one of the formulas that we learned in the first learning objective. So which is in fact formula number 2. So du over a squared plus u squared. So the squares is 1 over a arctan u over a. So let's have one u substitution first. And then let's convert the given integral to the one in formula 2. So now let's rewrite this integral. So this is dx over x minus 2 squared plus radical 3 squared. Okay, so I'm going to choose u to be x minus 2 and a to be radical 3. So the du here is exactly equal to dx. So now the brand new integral is du over u squared plus a squared, and that is equal to, by the formula number 2, 1 over a arc tan u over a plus c, which is 1 over radical 3 arc tan x minus 2 over radical 3 plus c. So that takes care of this integral whose bottom is a quadratic. Alright, so please go ahead and look at the tutorial videos. We have two different examples here. We have in the first one we have a quadratic in the bottom, very similar to the example I went through. So you have a different quadratic popping over there. And the second one, you have a radical term over there. So pay attention that once you complete the quadratic here to a square, so you're going to have another form in the formulas I showed you in the first learning objective. So please pay attention and please watch those videos in your own convenient times. All right, I'll see you in the next video. Bye.